Example 20, finding a triple transformation of a graph. We're going to use the graph f of x in figure 27 to sketch the graph of k of x, which is equal to f times 1/2, or f of 1/2 of x plus 1 minus 3. So here's our graph. So to simplify, we want to start by factoring out the inside of the function because we don't want to leave the 1/2 here. We want to factor it out to make our transformation a little bit easier, as we stated back in our definition. So by factoring the inside, we can first horizontally stretch by 2 as indicated by the 1/2 on the inside of the function. And remember that twice the size of 0 is still 0. So the point 0,2 remains at 0,2, while the point 2,0 will stretch to 4,0. So let's look at the factoring first. If we have 1/2 x plus 1, if we factor 1/2, then what's left is x plus 2. And you want to look at this as, if you distribute 1/2 to both of these terms, how are you going to get the original? 1/2 times x gives us 1/2 x. 1/2 times 2 is going to give us 1, which is how we get f of 1/2 times x plus 2 minus 3 by factoring out the 1/2. So that means we're going to have to horizontally stretch by 2. That means we need to multiply x coordinates by 2. So in our graph, we're going to look at those points. We have -2, 0, we have 0, 2, and we have 2, 0 from our graph above. So now again, we're going to horizontally stretch by a factor of 2 by multiplying all the x coordinates by 2. So 2 times -2 gives us -4, and then we have our y value that stays the same at 0. 2 times 0 is 0, and our y value stays the same at 2. 2 times 2 gives us 4, and our y value stays at 0. So now you can see what happens from this graph to this graph. We still have 0, 2, and now -4, 0, and 4, 0, so we can see that it's horizontally stretching. Okay, now we can see that we're going to horizontally shift left by 2 units, as indicated by x plus 2. Horizontally shift left 2 units means that we're going to subtract 2 from the x coordinates. So now we're taking the next coordinates, which is -4, 0, 0, 2, and 4, 0, and we're subtracting 2 from the x coordinates. -4 minus 2 gives us -6, and the y value stays the same at 0. 0 minus 2 gives us -2, and the y value stays at 2. 4 minus 2 gives us 2, and the y value stays at 0. So you can see here that now this has shifted over 2 units, because you have -6, 0, -2, 2, and then 2, 0. And then last, we want to vertically shift down by 3 to complete our sketch as indicated by the -3 on the outside of the function. So we're going to vertically shift down 3 units by subtracting 3 from the y coordinates. So now the x coordinates are going to stay the same, and we're going to take 0 minus 3, which gives us -3, 2 minus 3, which gives us -1, and 0 minus 3, which gives us -3. And now we're going to plot these points. So we have 6, -3, -2, -1, and 2, -3, and that is our final result. So this gives us our 3 transformations according to our original statement.